I guess I am live now. If anyone is around, can they confirm if audio and everything is fine? I guess I will start. Hello everyone, today I would be discussing the problems of Leetcode 380 contest. In the contest I solved all of the problems and had a rank of around 92 on the Leetcode US leaderboard. First problem asks us like first problem count elements with maximum frequency. You are given an array nums consists of positive integers. Return the total frequencies of elements in nums such that those elements have the maximum frequency. The frequency of an element is number of occurrences of that element in the array. And now if we look at the example, first example is 1, 2, 2, 3, 1, 4. And the output is 4 over here. It says that element 1 and 2 have a frequency of 2. If we see here, like 2 appears 2 times, 1 also appears 2 times, 3 appears 1 time, and 4 appears 1 time, which is the maximum in the array. Because 3 and 4 appears only 1 time and 1 and 2 appear 2 times. So like the maximum times a particular number appears is 2. So the number of elements in the array with maximum frequency is 4. So like, and if we look at the numbers which are maximum times, like 1, 2 are the ones which are maximum frequency, and if we look at how many times 1 and 2 appear, that their count is 4. 1, 2, 3, 4. Similarly, if we look at the next example, it's 1, 2, 3, 4, 5. Like all the elements of the array have frequency 1, which is maximum. So the number of elements with maximum frequency is 5. So like I will mostly code it up directly, and like there are many ways to do it, like using the fact that the length is less than 100 and the number of each element is less than 100. One way to do is we can maintain a frequency array of length 100 and add everything over there, find the maximum, and then count how many times all the numbers appear. Some people can also use map over here. I will go with frequency array because we are given that all the elements are in range 100. We can create a 101 length array. Now when we first iterate on it, now let's find the max frequency. Now let's count like how many numbers have which appear have maximum frequency. Like let's run it on samples once. Okay, it should be frequency. Wait a second. Max frequency 1 is fine. Then I'm iterating on all the numbers again. Okay, yeah, frequency it will be frequency. So like maintain a frequency array, iterate on all the elements and add one to their frequency count. Then find the maximum frequency and then iterate on all the numbers again. Look at the frequency of each element. If it's equal to maximum frequency, add +1 to the answer and return the answer at last. Any questions on this one? Probably I will move on to the next problem now. The next problem has two parts, B and D. One is the harder part. Here we are given a zero index string S, a string A, a string B, and an integer K. And index I is beautiful if 0 is less than I is less than equal to length of S minus length of A. And if we look at the string from I to I plus length of A minus 1, then it should be equal to A. And then there also exists an integer J such that 0 is less than equal to J is less than equal to length of S minus length of B. And S of J up to J plus B minus 1 is equal to B. And absolute value of difference of I and J is K. And then we have to return the array that contains beautiful index in the sorted order from small to large. Let's look at the example over here. First example is ISAWS QUI RREL is squirrel near my squirrel home. And then A is my, B is squirrel. And if we look at our original condition, first condition, this essentially means that if we look at the string which starts from index A and is equal to the length of A, then it should be equal to A. Like essentially that's what it means over here. And if we look at in the first example, A is my. So let's look at all the places where my appears. My is here and my is here over here. Now let's look at all the indexes where squirrel appears. Like second condition means find all the indexes J where if we look at string of length B which starts from J, then it is equal to B. In the second case, squirrel appears here and squirrel appears here. And if we count the I indexes where all of these appears, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 18, and like this would be 33. So like number of possible values for I are like number of indexes where a position like A appears is at index, like squirrel appears at index, like B appears at index j equal to 4 and j equal to 18. And if you look at the indexes where A appears, A is at index 16 and 33. So like these are the places where I appears. And what we have to print is find all the I where string A appears, and there should be a string, there should be an index j near that I such that absolute value of A minus I should be less than k. In the first sample, k is 15. So like if we look at it, like for I equal to 16, we have a j which is at index 4, such that the difference of 4 and 16 is 12, which is less than equal to 15. Similarly, for I equal to 33, we have an index j at position 33. Wait, for I equal to 33, we have an index j at 18 such that the difference is less than equal to k. In the second part, if we look at again, it says A, B, C, D is there, A is A and B is B. So the number of possible I are first index only and number of possible j are first index only. And if you look at the difference between them, which is 0, which is less than equal to 4. Here the constraints are special. It says length is up to 1e5 and A and B is less than equal to k, but there are no additional constraints on k over here. So like let's do a brute force and find all the places where I appears, A appears. We can use the C++ function s dot substring to find the string which starts at length I, which starts at index I and has length A. And we can check if it's equal to A, then insert this index at the back. Similarly, we can do for FB. We can use a similar for loop to find all the indexes where B appears. Now we can do multiple things. One way to do is we can maintain a two pointer, or we can also use the fact that this is sorted, or we can sort them and try to binary search for the nearest j for each I. Because we are like because we are running in an increasing order of 5, we can assume that FB and FA are sorted. If required, we can even sort them otherwise. To find the nearest element, we can do binary search using the lower bound function of C++. In that case, we know that the number just below it would be, we can also check the smaller element less than I. This should solve our problem for now. Like here, I'm binary searching to find the nearest element index 0 for each I. Like I can write an explicit binary search or use the lower bound function. Now I can also do it using sliding window technique, because I know that I is in increasing order. The nearest j would keep on increasing over there. Now the same idea. Now I will move to problem C for now, and we will come back to B later. Hello everyone. Yeah, hello Anubhav. It says maximum number that the sum of prices is less than equal to k. Consider S is one index binary string of integer nums. The price of number num is the number of ones such that I modulo x is equal to 0 and Si is a set bit. Return the greatest number nums such that the sum of prices of all the numbers from 1 to nums is less than equal to k. Note, in binary representation of a number, set bits is a bit value 1. The binary representation of a number will be an index from right to left. For example, if s equal to 11100, like it denotes the number 4 plus 8 plus 16, which is 28, and it says s4 is 4. If you look at from this side, 0 1 2 3 4, like this is the index 4, and s2 is 0, like 1 2, like this is the index which is at 2. Now here the constraints k is up to 10 to the power 15 and x is up to 1 to the power 8. So we cannot definitely run a for loop. Yeah, like TLE is expected because x is up to 1, 10 to the power 15. So if you have k equal to 10 to the power 15 and x equal to 10 to the power 8, like the final answer would is around 10 to the power 18 or something like that. So you cannot run a for loop for each index, check how many numbers you can do. So we need something smart over here. First thing, like let's define a function on which we will do a binary search. Like I am not sure like how others did it. What I did was digit dp for this solution. I will add it like what is it as in the comment of the stream, and I will try to go through the idea a bit. So like first thing we should know that let's define a function f of n as sum of prices of all the numbers from 1 up to n. Now if you look at f of what is f of n plus 1, which is sum of 1 prices for 1 up to n plus 1. This sum is also equal to sum of 1 up to n plus price of n plus 1. And if you notice, sum of 1 up to n is f of n plus price of n plus 1. And now if we look at this equation, then the prices is number of indexes in n plus 1 which satisfy some condition. And we can notice that such count will always be greater than equal to 0. So here if we try to plot a graph where n is on x-axis and y-axis is f of n, then at 0 the count would be 0, at 1 the count can either be 0 or 1, but it's always increasing over there, like it looks something like that. So what we can do is, like whenever you see a function which always increases, or if you see a function which is true for some time and then it's always false, or it's false for some time and it's always true, like we can try to do a binary search on them. Like if you look at it, if you define a function g of x as f of x less than equal to k, then there would be some index such that these values would be true, like where f of x would be less than equal to k, and after that f of x would always be greater than equal to k, so false, false, false. So whenever a condition like this appears, which is true for some time and then false always, or it's reverse, like it's true for some time and then it's false, and you are asked to find the index where this behavior changes, then you can do a binary search to find that index. So in our case, now we need two things over here. Some smart way to find f of n, which is sum of prices of all the numbers up to n, and then binary search for this f of n to find the greatest number. So like I will first code this part and then I will try to explain like how to do binary search. Like I will mostly use Python over here because like digit DP or probably yeah. Like this long at the output should have given you the hint. Like answer can be possible. It's possible that the answer is more than 10 to the power 9. So running a for loop can give you a TLE. Low high. Let's use low high terminology. Like there are different implementations for the binary search. Let's say f of x takes mid and x. If this comes out to be less than equal to k, then we can increase our low, else we should decrease our high, and at last return low. So like, how do I know the range of binary search? To be honest, I don't. Like, I just try to guess it over here, and I also got one WA because my initial range was small. Like, a simple way to do would be like, you need k numbers, right? And you know that if the number, if if a number is a multiple of 2 to the power x, like if the number is of form, let's say not 2 to the power x, let's say k is equal to 2 to the power x, then any number of form, like any number of form 2 into I plus 1 into 2 to the power x will have at least one bit. So like, we can try to take an upper bound like this over here. And if you notice the constant, k is up to 10 to the power 15, x is up to 10 to the power 8. So 2 into 10 to the power, so like our, no, I will let me call p. So if we take I equal to k and put it this equation, we know that the answer would be definitely less than equal to that number. And in our case, that would be 2 to the power 8 into 2 into 10 to the power 15 plus 1. And you can take some buffer over here, let's say 100. And this number is definitely less than 10 to the power 18, is how we can calculate. And like, there are other ways to do it as well. Like, let's say you have no idea like what can be the maximum search. What you can do is you can start with high as 1 and run a for loop while high of, like, keep multiplying the high value by 2 as long as that value is true. And because we know that eventually high would become false, so like this will ensure that after this loop terminates, high would be false and low would be true. So now you can do a normal binary search after that. So like, if you have no idea, like you can use this technique. And like, if you have some reasonable estimate like what should be the range for binary search, then you can directly code that. Looks good. And okay, now we can use our same idea again. Like, this would be the smallest, like if you want x index, like if your x is 1, then you know that the smallest place would be the 0, the last place. If x equal to 2, then the smallest place would be the second last bit, or something like that. Like, or probably the other way to do it, I found it easier, was to do a digit DP. Like, the idea in digit DP is you try to construct it and try to find the range for all the numbers. Like, probably I will first check if what did the other guys do. Okay, like here they are trying to do it in some order one. Okay, here they are trying to do it in some blocks as well. Like probably I will just say DGDP because once you learn DGDP, like the problem like this would be easier and you don't will not have to figure out the specifics of the problem. For DGDP, first we need a binary representation for the given numbers. Let's try to find all the numbers which are less than equal to 1. So we can increment it by 1. Like here now you will have the binary representation of A. To find the binary representation of A, what we can do is we can try to take the last bit, which would be 0 if the number is even and odd if the number is 1. We can try to find the last bit and then we can divide the number by 2. So for example, if you look at the number 11, then its binary representation would be, since the number is odd, add 1. Like let's say if you want to find binary representation, first check if the number is odd or even. Number is odd, so put 1 and then divide 11 by 2, which would be 5. Again the number is odd, add 1 over here, divide it by 2. 5 divided by 2 is 2. Now the number is even, add 0 over here, divide it by 2. Now the number is odd, add 1 over here, divide it by 2. So binary representation of 11 is 1011. Because I am adding it in that order, I am doing a dot pushback over here. Now we can try to do a recursive function. I will call it DGDP for now. Like probably let me just define. Like you can write a recursive function inside this over here instead of using global values like this. Like here is the return, so you add it over here. Like generally in DGDP problem, you need 2 indexes. The number of indexes you have processed in A so far, and a constant boolean type, which says are we restricted over here. Like I will share some resources and some problem or practice problems to solve for it in the comment section. Now if we reach the end of array, then because we have incremented it by plus plus over here, here I am returning as a pair is count of numbers processed and count of those indexes such that I modulo k is 0 and the bit is set. If type is true, we return that. Otherwise, the count is 0, but the numbers becomes 1. Bits count and like maximum we should process. In DGDP problems like this, if type is true, we take AIDX. Otherwise, we take max as 1. Like in binary, we take max as 1. If it's base 10, we take as 9 and something like this. IDX plus 1. Either if type is true and current digit is equal to max, then only the type remains true. Now bit count plus equal to CLD dot first. Number count plus equal to CLD dot second. And because we know that current IDX, because we are counting it from here, like we are not counting I from this side, we are counting I from this side. So current I would be size of A minus the current index we are processing. If I percent x equal to 0 and then current digit or bit equal to 1, this condition, like if I percent x equal to 0 and SI is a set bit, set means 1, then we have to also increment the number of possible bits which are over here, which would be equal to the numbers, possible numbers we got over here, plus this should complete our algorithm. Okay, I am getting runtime somewhere. Okay, like I can do it other way as well. Like because we are trying to find it over here, I can do pop front as well. Idea in generally binaries, we look at if the number is odd or even. If the number is odd, then the last bit is 1. If the number is even, the last bit is 0. So we to check whether it's odd or even, and then we recursively try to find all the bits before it by dividing n by 2 again. And because I was doing at push front, like if you do not want to do reverse, you can also use push front. But beware that push front takes the time complexity for push front is big O of the length of A, while pushback is big O of 1 over here. In our case, I know that like this length would not be more than 60. Probably I did not understood. Like we can do it the other way as well. Like right, like I am unnecessarily complicating it. You are right. We can just keep it pushback, and just that instead of starting from index 0, I will have to start it from a dot size -1, and then I will have to look at if index becomes -1. Like this is the other way to do it. No need to reverse it. Just generate all the bits from the lowest index. You start from the highest bit, go until the last bit, and here now you don't need a dot back. You can just take idx over here. Like it's more of a way of how people like to code over here. And mhm, looks like I am missing something. My first answer is fine. Second, it says 9. Right, we have a zero base indexing, right? Like current number is displaced by 1 a bit. Okay, it says TLE. Okay, yeah, I forgot to memorize it using a dynamic programming over here. So it's essentially order of n only. One for right. And I need a vector of pair as well. It's a dot size as well. Like someone is knocking on the door. I would be back in a minute. Like if you have some questions, you can ask on chat. I guess I am audible now. Like generally, if I have to refer to some resources or advise some, I generally go for user guide, competitive programming handbook. Both of them have resources for DigiDB. It has marked it as gold, which generally means around 1600 at least. Like counting things. Okay, looks like this does not have. Like I believe my way of writing code is not something you should write in production. At least the one I use for code forces. Like there are a lot of bad habits over here. Like I don't see digit DPs there, but I think CSES problem set has some digit DP. Like it's generally about the speed. Like the way I write code, like it helps me code faster and save some minutes over there. Yeah, I don't know if CSES has something on digit DP or not, but USAO guide is also used. Like I generally use Y Combinator, just that right now I did not wanted to put it over here. Like this type of function has some advantages. Like people say it's relatively slower than Y Combinator. Like my preference is Y Combinator, just that here I was coding it from scratch, so I have used recursive lambda. Now moving to the last problem again, like USAO guide, probably you can read it about here, or like there can would be some YouTubers as well who would have created it. Since it's part two, let's first copy our solution of earlier problem first and just submit once. It will get a TLE, memory limit TLE, everything is here. And if I look at the difference over here in this problem and this problem, here it says length of A and B is less than 10. Here it says the size of S also increased by 10 and A and B is also up to 5v5. So the slowest part in our code here is this: finding a substring, comparing it, and finding all the matches. If we can somehow reduce the time complexity over here, you will see that this is order of number of occurrences would be, that would be number of lengths of A. And like this part should be fine. This is the place where we need. So like if we put it in terms of requirements, we need some method. If s up to I from equal to A, if we can do this in, let's say, after some pre-processing in order of 1, then we would be able to do it in order 1. Here we are running an order n loop, so overall the time complexity would be order n, and this one would also be order n. Now there are multiple ways to do it. I will list down some of them. One is rolling hash, and I will share some resources on them, and I will probably avoid coding. Second is KMP function or like pi function. So few people also use some JAD function or something like that. Like we also have something known as suffix array. We can also use that to find things over here. Like you probably don't need this. In the context, I use KMP or pi function, and rolling hash would be the other method to do it. Back to our user code guide. Like here you can find about like KMP algorithm. And I believe CP algorithm has like CP algorithm also has KMP. Like I pretty much picked it over here. And if you look at the definition of prefix function, it says you are given a string S. The prefix function of this string is defined as an array pi. You can call it A as well, of length L, such that A or pi of I is the length of longest common prefix of substring 0 to I, which is also suffix of a substring. Too many definitions over here. Like I will try to explain it a bit. I will not go into the details of algorithm why the code for finding this works, but I will try to explain like what does it do. Like for now, let's assume that prefix function is a black box for us. What it does is it takes string S as input, and it gives us an array as output, where the length of A is equal to length of S. And it says like the value of AI of X will be the maximum length which is less than I. Like if you look at the string from I equal to 1 to I, it will give a maximum index length such that S of 1 up till length is equal to S of I minus length up till I. So for example, let's take if this problem has some okay, I will just take some example from my side. Let's pick an arbitrary string A B C A B C A B. Then if you only look at this character, like we do not have to take the whole string. Then the maximum length, which is also at the starting part and the ending part, is 0. For A, B, you can see that the maximum numbers starting which match with ending is also 0. That would be 0. For C also it would be 0. Now the interesting part is A, B, C, A. If we look at it, like the length, like first character is equal to last character. So the what we can say is the first one character is equal to the last one character. So here the value of prefix function would be 1. Now the things become interesting if we add AB over here. What we can see is like if we look at the string with first two characters, it is also equal to the string as the last two character. So here the value of A would be 2. Now if we add C to it, like we can see like first three characters are equal to last three characters. So prefix function over here would be 3. Now if we add A again, we can see that ABCA is equal to ABCA. Overlapping is allowed, just that you don't have to take the complete string. So here you take 4. And ABC, ABC, AB. Here if you see, the first 5 characters are equal to the last 5 characters. So this is equal to 5. Yes, it's the KMP algorithm. So now if you want to find if a particular string A exists in S, what we can do is we can create a new string T such that A plus, let's pick some character which is not in both S and A. Like I took a dollar sign plus S. Now if we run the KMP algorithm over here, like then we know that like this character can never match with any other character. So if in T we have, let's say if T up to, let's say, J, such that the first length of A characters are matched with the last A characters, then we know that the string starting at J minus len A would be equal to A. Because we have added these many characters as well, we have to take into account for finding the index as well. So the next step here would be like I took the KMP algorithm as it is. Let's start from the index where we have added dollar first. Uh, I will call it S index. Like because we have added a dollar sign, so like PI would be at this much place. Similarly, we can find all the places where B exists. Like the remaining algorithms remains the same. Looks like I'm messing up with some indexes somewhere. Okay, this should be B. Right. Let's check it again. Like what does prefixing? It's returning the length equal to I. So if I start SI from 0, Length of a plus 1 are the characters I have added. Like these are the number of characters I have added, and here it should be plus 1. So this pretty much completes my stream for today. If there are some questions I can take, otherwise I will call it off and we can end it now. Thanks everyone for joining. And I would also be discussing ad coder beginner contest today after it ends around 8 p.m.